Today we're going to do some fun demonstrations that you can do at the Thanksgiving table. We're going to call these our Thanksgiving science demos. Chemical reaction between Coca-Cola and milk. So I'm going to take the cap off. I use a 16-ounce small bottle of Coke. You want to drain a little bit of the liquid out. I'm just going to drink a little bit off the top. Okay, now we slowly pour the milk, slowly so it doesn't fizz over. Pour in the milk, and this is going to show a very interesting chemical reaction. So you fill it, you set it off. Now you put the lid on and then just kind of mix it without shaking it. You just want to mix it. Okay, and then you let it sit. And after about a half hour, we're gonna let it sit. After a half hour, this has been sitting for about 2 hours, we get this. You can see how you have a clear liquid on the top, that's water, and at the bottom you have this disgusting sludge-like material. So what happens is the phosphoric acid in the soda reacts with the calcium in the milk, and it actually strips the calcium off the milk. And at the bottom you have this substance, this phosphoric acid and calcium mixture. And what it does is, think about it, over time, if you drink soda for many, many years, over time, it will weaken your bones. It'll make your bones less dense. And then you get older, that can lead to osteoporosis. So a good example of why we shouldn't drink too much soda, okay? Okay, second demo involves a soda can shake. Here I'm using a can of bubbly so I can shake it up. Okay, give it a really good shake. People are gonna look at you like you're crazy for shaking up a carbonated beverage. Shake, shake, shake. Okay, give it a few flicks. Open it up. And you can see that it fizzes a little bit, but not too much. Okay, a little bit. I probably should have tapped it a few more times. This is really carbonated, but you can see that by flicking it, you kind of diffuse it. You take the bubbles out and you don't get that much of a mess. This does not work with diet soda. Only regular soda or bubbly, sparkling water. Still a little bit of a mess, but not too bad. Okay, demo 3. Okay, demo 3 involves a scene wine glass. I'm gonna pour some cranberry juice into this wine glass. So at the Thanksgiving table, you can take your uncle's wine glass and do a little science demo. Here we have 2 wine glasses. Okay. Dip your finger in. You can press on it, make a force vibration, and the wine glass will sing. With a little practice here, dip it in again. Almost got it. Ready? There it is. You can really get it to sing real loud. Try the other one. Okay, this is another wine glass. A little lower pitch, bigger wine glass, less liquid. And you can adjust the pitch. If you add less wine, you'll have a higher pitch. Less wine, higher pitch. So you experiment with that. Takes a little practice, but fun little trick, the scene wine glass. Okay, next demo, demo 4. Okay, we're gonna try some floating and sinking demos. Here we have a regular orange versus a peeled orange. We put them in the water. Okay, watch the regular orange, which this has more mass because I took the peel off. So this one has shedded some of the mass, took the peel off. So we put the regular orange in, and it floats, density less than 1. Put the peeled orange in, and it sinks. Okay, science behind that. If we look at the peel here, it's got a lot of air pockets in the peel, so even though it lost its peel, because of the air pockets in the peel, okay, that causes the regular orange to float. All right, now if I take cranberries, popular Thanksgiving treat. Food, take cranberries, float or sink. These cranberries, float or sink. Put them in there, They float high. They float high. Here's the reason why. If I take a cranberry quickly and dissect it, dissect the cranberry here. If we look inside, we'll zoom in here. We can see that the cranberry, I don't know if you can see that, but it's got a lot of air pockets inside. So inside the cranberry, there's a lot of air, which causes it to float, causes the density to be less than 1. All right, if I take craisins, these are dried cranberries, which regular cranberries, they have a real, kind of a sour taste to them, real sour. Dried cranberries taste really good because they are loaded with sugar. Tastes great, lots of sugar. Watch what happens when I put the dried cranberries in. Okay, they sink because the sugar, here's a couple of photos, but the sugar weighs them down. Sugar weighs them down. Okay, here's another good one. I'm gonna take my wine glass, okay. Wine glass, transfer it in. Okay. All right, take my carbonated beverage, bubbly. Okay, take some craisins. Will these float or sink in the bubbly? Let's see here, ready? Answer. If we watch, they do both. They will float and then sink. So as they come up, they float because they have bubbles on them, and then once the bubbles dissipate, then they sink. So this will go on periodically for about an hour. They float and sink, float and sink. So see how they come up, and then once the air goes away, then they sink. As they get more air bubbles, they float, then they sink. So a cool little demo, often done by 7th grade science. Okay, this next demo is called the Volcano. Here we have some little bit of cranberry juice, put it in a cup. Okay, notice how the color is red. Okay, I'm gonna add some baking soda to it. Add some baking soda. Mix it in. See it bubbles up. Okay, we got a color change. It is now more of a purplish black. It became a base. Now it's a base, color change. If I add more acid, and I'm gonna add some vinegar to it, add a little vinegar to it. Boils over. Vinegar's an acid, so now we have, it's back to the reddish color of the cranberry juice. Now it's back to be red because now it's a base again. If we add more, I'm sorry, it's an acid again, I should say. If we add more baking soda, we can get it back into a base. Mix it in. Looking for a color change. Okay, now it's back to being more of a purplish color. More purplish color. If we want to get back again, we can add more vinegar to it. Goes over. Okay, so a good example of color change. All right, last demo, and I would not advise trying this at home. Okay, this is called our tablecloth trick. So you just go over here. Okay, so this works really well if you have like a smooth, silky tablecloth with no hem. You can put some dishes on it. You can weigh it down. I definitely want to add some weight to it. So in this case, I'm going to take a flask and put my coffee mug on top. Now I don't have a tablecloth, but I have a smooth sheet of paper here. And you just walk up and you say, this tablecloth has a spot. I need to get rid of it. And there it is. You took the tablecloth right out. Oop, almost fell. You got to pull it straight down as hard as you can. Again, practice that first. Don't try it at home. That's a tricky one. You could have a great demo or an epic failure. Okay, well, thanks for listening. These were 6 or 7 classic Thanksgiving experiments you can try at home. If you try them at home, let me know how it goes. Have a great Thanksgiving. There's a lot to be thankful for. Enjoy the time with your family. We'll talk to you soon.